Kia ora Year 12 and Year 11. This is a video on parametric differentiation. So I'm making this for the boys who were away on the Duke of Ed trip, but also for the whole class when you come to revise parametric. It's not as easy an example as the ones that are done first in the textbook, but it goes over a couple of the basic things and it's quite a cool curve. So hopefully this won't be too long. So we're going to work with a function that looks a bit different from our usual functions. So when we start out in maths with the idea of a function, we have things like this. Y equals 4x plus 3. We take an x value and we times it by 4 and we add 3 to it. Right? We think of that often as a function machine, and out pops a value of y. Now what we've got here still gives us a relationship between x and y, but it comes through a third variable which we call a parameter. So in this case I've got theta, and theta affects x and theta affects y. So x and y, something weird is happening here, x and y are related, but it's not obvious how that is. So what I've done here is I've drawn the curve, but first I want to tell you what I want us to work out. We're going to find the gradient, dy by dx, and then we're going to find the equation of the tangent when theta is equal to pi on 3. Because what happens here is as I change my parameter, I trace out a curve, because that parameter defines an x coordinate and it defines a y coordinate. So the curve here looks like this. Oh, no it doesn't. It looks like this. And we're going to find the equation of the tangent when theta is equal to pi on 3. The only thing is I have no clue where that point is just yet. So I'm going to figure out where that point is by using x equals theta minus sine theta and y equals 1 minus cos theta. Now I might as well get that bit out of the way now because I'm going to need that information for later on. So let's draw our little special triangle. We really shouldn't need this by now. Sine of pi on 3 is root 3 on 2, and cos of pi on 3 is 1/2. So what's x? Well, x is going to be root 3, no it's not, it's going to be pi on 3 minus root 3 on 2. And y is going to be 1 minus 1/2, which is just 1/2. So here's my x coordinate, and here's my y coordinate. And we're going to work with exact values. Right, so x, written out nicely again, is this, and y is 1/2. So when you want to find that on the graph, you are going to need to go to a decimal approximation. I'm pretty sure it's about here, right? Or might be slightly further down. But this is where we're looking for the equation of the tangent. So there's my tangent line in there. All we have left to do now is to figure out what is dy by dx. So to do this we're going to use the chain rule. Dy by dx is equal to dy by d theta times d theta by dx. This one I can get really easily. I've got y equals 1 minus cos theta. So that gives me dy by d theta is equal to negative of negative sine theta, which is just sine theta. Right? It's fine to go straight to that line. You don't have to do that one. Okay, that's just because we're still getting used to differentiating trig functions. Now what about d theta by dx? Well, I don't have d theta by dx. But I know that that's equal to 1 over dx by d theta. Now I talked in class about how this works for quite a while, so I'm not going to do it all again in the video. If you were away, I will show you some basic intuition behind that. But what this means is that I can use this to help me find this, because we've got x equals theta minus sine theta. So it's really easy to find dx by d theta. It's equal to 1 minus cos theta. So putting all that together, this is what we get. Dy by dx is equal to dy by d theta times d theta by dx, right, which we can't get. So that's equal to dy by d theta divided by dx by d theta. That gives me, using what we did above, 1 minus cos theta, no, So that's y, not dy by d theta. So it's sine theta divided by 1 minus cos theta. So there you go. We're using the chain rule, and that's given me very, very quickly the first derivative. Now what I have to do to get the equation of the tangent is what happens when theta is equal to pi on 3. Well, dy by dx is equal to sine of pi on 3, so root 3 on 2, divided by 1 minus 1/2. So that equals root 3 on 2 divided by half, which is just root 3. So now I'm ready to find the equation of the tangent. Y minus y1 is equal to m times x minus x1. And we know that the point defined by that value of theta is this. It's pi on 3 minus root 3 on 2 and 1/2. So off we go. And remember, we're going to keep with exact values. Please nobody switch to decimals now. So we get y minus 1/2 is equal to root 3 times x minus pi on 3 minus root 3 on 2. So y is equal to root 3x plus root 3, minus root 3 on 3 pi plus root 3 times root 3 on 2 plus the 1/2 from over here. So cleaning that up, here's the equation of the tangent in y equals mx plus c form. So root 3x minus root 3 on 3 pi plus 3 over 2 plus 1 over 2 gives me plus 2. Now I'm just going to hop over to GeoGebra and show you what that looks like in GeoGebra Live. Where's it gone? Oh, disappeared. We can put that equation on there. There we are. There's the tangent there. So my point's about, my point won't work. I can't draw. Sorry guys. But that red line is the tangent line. Going back to OneNote where I've done it ahead of time, here's my curve here, right? So slightly too far up, but hopefully you've got the idea. Right, so here's the equation of the tangent at that point there. Okay, so exercise 4E is really, really good, and full worked solutions to it are up on Google Classroom. So make sure you do lots of these. It comes up quite often in level 3 as well. The only two skills that I haven't done in this video that are important, but too much for tonight, are how to find the second derivative. And that's just another application of the chain rule. Okay, and also how to look at minima and maxima around parametric curves. Okay, but we'll save that for another day. Thanks for watching.